Hello AI fans, welcome to the Data Speaks. In this video series of building Agentic AI Chatbot using Hugging Face model that enables the web search. This chatbot specifically is called Tool Augmented Chatbot, or we can call Agentic Chatbot. This is not definitely RAG because we are not using embeddings, vector databases, chunking, or similarity search. This is neither full autonomous agent because we are not using planning, tool selection, memory, and multi-step action loops. However, this is a tiny demonstration of Agentic AI foundations so that you have some idea of how Agentic AI actually works. We will be beginning with installing required libraries and modules, then we will be importing them that is required for the chatbot. We'll check the CPU and GPU availability based on computer, and also we want to ensure that our computer is capable enough to handle the complexity and the load of the large language model. Then we will choose the Hugging Face model that we are going to use for the chatbot solution. And then we are going to load the Hugging Face text generation pipeline, including the model here. And then we will next do is test the model without web search. How does it do when responding to the user's question? Then we will add a web search to validate if the accuracy of the model increases using the web search. Once we build the solution, then we will test the web search functionality if it is actually working or not. Then we will convert the search result into the context that user has asked the question for. Then we will build the prompt. That's going to be the instructions, the rules that chatbot needs to follow while responding to the user's question. Then we will build a final web search augmented chatbot function. Finally, we will test the final chatbot, and also we will be building interactive chat loop so that users can keep asking questions until all the questions are answered. Then at the end, I will show you a final surprise solution that will blow your mind. So please do not forget to check all the videos in this series, and I promise that you will be benefited a lot. And if you have not already subscribed to my YouTube channel Data Speaks, please do so and hit that like button for this video and share with others too. Let's straight dive into the tutorial. We will begin with installing necessary libraries and modules. That will include Transformer, Accelerate, Towards, DDGS, and Streamlit. So Transformer is used as a Hugging Face model loading and pipelines. Then we will have Accelerate to automatic model device placement, and then Towards is for the deep learning backend. And here DDGS is the web search framework for Python. And then here we are building web application using the solution. We will be installing all of them into our terminal. It is really important to use the terminal because we want to keep our notebook clean enough and we have no issues on accessing all libraries and modules as we have installed. To do that, we will begin with installing our virtual environment and activating them. In the terminal, I will just simply go ahead and run our virtual environment. I will call python-m venv, and I will give the name .venv. You can give any name you like to. This way you are installing a virtual environment on your computer. Then we want to activate virtual environment, and that is very simple and easy. If you simply open a new terminal, mostly the new terminal will come with the virtual environment activated if you have a .venv there. Otherwise, you will call .venv bin/activate, and that will activate your virtual environment. Then all the libraries and module you will install for this project is going to be inside .venv virtual environment. Let's install Transformer, Accelerate, Towards, DDGS, and Streamlit in our virtual environment. So once that is installed, we'll be able to use them and start building the solution. Now, once you have installed all the necessary modules and libraries as listed over here, Transformer, Accelerate, Towards, DDGS, and Streamlit, we will need to import all of them libraries and modules as necessary. Python's default text wrap will help us to format the text outputs. Then from typing module, we are going to import list, dict, and tuple to ensure we have our data types for our functions and classes. Then we are importing Towards the edge we have installed, that is deep learning operations and model handling package. Then here we are importing pipeline from transformers to load all the pipeline steps that handles the question answering. Then we are loading DDGS, DuckDuckGo search framework, that is required to perform the web search. Here, the reason behind using DDGS is because this doesn't require API keys or any authentication from the web service provider, unlike Google and Microsoft Bing and so on. This is really powerful yet simple to use for any large language model based solutions. Then here we are going to just quickly check the availability of GPU and CPU. Want to ensure that our computer is capable enough to handle the complexity and load of the large language model. So simply if we run this, we are going to get information about if the GPU is available or not. Otherwise, it will simply run on the CPU. So for my computer, it said GPU is not available, model will run on the CPU. That should be fine because I have seen that my computer works just fine for the tiny or middle level of the large language model. So without any issues, we will be able to develop this solution. Then next one is going to be selecting the model from Hugging Face framework, Hugging Face platform. So this model, the TinyLlama 1B Chat v1.0, so this model comes from Hugging Face. So Hugging Face is the platform that has millions of models that you can use at any point of time based on the use case and computer's capacity, plus what cost you can afford to use and what use case you have to develop those models. So we will go to the Hugging Face and quickly see the TinyLlama there in the platform. If you go to your Hugging Face platform, of course you have to go to the huggingface.co and create account if you do not have already. Once you create the account, just simply search for TinyLlama 1.1 billion Chat v1.0, and that is the very first search result here in the Hugging Face. If I click on that, the dedicated page for the TinyLlama will open. And if you like to just see how does it work and some documentation, some basic information about Hugging Face, you can definitely refer to those. It is always helpful to understand what model you are using and what capabilities it has and what all the information you can consume from the Hugging Face framework. So this is the model we are going to use in our chatbot. Let's define the model ID that we are loading from Hugging Face, and once you run it, now we have this model ID executed. So we're not yet using the model. Now that we have selected our Hugging Face model, the next step is to load the model into memory so that we can start generating response from it. To do that, we are using Hugging Face pipeline function, which is one of the easiest way to work with large language models. Here, what we are going to do is creating the text generation pipeline and storing them inside a variable called chatbot. You can think of pipeline as a ready-to-use wrapper that handles tokenization, model loading, inference, and decoding behind the scene. Instead of manually writing all of those steps, Hugging Face gives us a simple interface through the pipeline. Now here comes the task, which is the text generation. Since we are building a chatbot that generates text responses, we are using the text generation task. Next comes to selecting the model. Earlier, we had defined the model ID in the step number 4 here, the model TinyLlama. That's what we are going to select as our large language model for this chatbot. Then next comes to the optimizing the memory usage and the performance. If the GPU is available, we are going to use float 16, also known as half precision. Half precision requires roughly half memory compared to the float 32, allowing larger models to fit into the GPU memory, often improving the inference speed. Now, if the GPU is not available, then we fall back to float 32, which is the standard precision commonly used in CPUs. That makes our code flexible because it can run on both GPU and CPU systems. Device map equals auto is another very useful parameter. Value auto tells the Hugging Face and accelerate to automatically determine where the model should be loaded. If GPU is available, it will be placed the model on the GPU. If the multiple GPUs are available, then it can distribute parts of the model across them. And if no GPU is available, then it will automatically use the CPU. This saves us manual efforts on managing hardware resources. Once everything is set up, we want to confirm that all the steps are appropriately loaded. So we want to print the message that the model has successfully loaded. So this way, we are initializing the chatbot pipeline that we are going to use to build our chatbot. So this is all in this video. In the next video, we are going to test the model first without the web search tool integrated with it. So we want to ensure that we are building the solution when needed. And also it gives us the capability how web search augmented tool will help to improve the model's performance in general. So please do not forget to check my next video in the series of this chatbot, and I will see you in the next video. Until then, please enjoy learning.